Hey everyone, and welcome back to On the Radar. I'm Eric Hillsberg, and this is something new that I'm going to try out, a deeper dive into the most significant aerospace and defense updates that have been emerging across the industry. A quick disclaimer, many of the companies that I'll discuss today may be customers of MathWorks, but the views that I'm sharing are entirely my own. Alright, let's unpack what's really happening, why it matters, and where these innovations might take us. Grab your favorite beverage, get comfortable, and let's get started. We're starting in space, where the nature of competition is clearly evolving. Nations aren't just focused on reaching space anymore. They're positioning themselves to control the infrastructure that could define how space operations work in the coming decades. Let's start with what might be the most strategically significant development we're tracking: China's systematic build-out of cislunar infrastructure through their Deep Space Exploration Laboratory, or DSEL. This critical region of space between the Earth and Moon is where the next chapter of space competition is being written. China just deployed several small spacecraft, DRO-A, DRO-B, and Tiandu-2, into highly specialized orbits. DRO-B, for instance, is now operating in what's called a 3-to-2 resonance orbit. Every time the Moon completes 2 orbits around Earth, DRO-B completes 3. It achieves this by taking a tour of the Earth-Moon Lagrange points L3, L4, and L5. These Lagrange points are essentially the high ground of cislunar space, prime real estate for future infrastructure like communication relays. Whoever establishes infrastructure at these points first gains significant operational advantages for all future lunar and deep space missions. Tiandu-1 is operating in an even more complex 3-to-1 resonance orbit. And while DSEL claims it's the first in this orbit, NASA's IBEX spacecraft operated in a very similar configuration previously. The difference, though, is that China's doing this as part of a systematic infrastructure campaign, not just scientific exploration. It's worth noting that there have been some issues for the Chinese spacecrafts. Both DRO-A and B suffered damage on their solar panels upon launch, and Tiandu-2, which was launched alongside Tiandu-1, appears to be suffering from other issues. Closer to Earth, China appears to be testing out other strategic capabilities. Chinese satellites are believed to be attempting something that could reshape the economics and military balance of space operations: the first ever onboard refueling between satellites. Satellite tracking firms Slingshot Aerospace and Comspock observed China's experimental SJ-25, specifically designed for refueling missions, make a close approach to another satellite, SJ-21, on June 13th. They came within 1 kilometer of each other, and while the data was inconclusive for actual docking, the second close approach is predicted for June 23rd. Now, why does this matter so much? Well, think about it. If you can refuel satellites in orbit, you've essentially solved one of the fundamental limitations of space operations. Satellites no longer have expiration dates tied to their fuel supply. They can change orbits, extend missions, and perform maneuvers that were previously impossible. But there's also a darker side to this capability. The same technology that enables peaceful refueling can be adopted for what we call counter-space missions. Essentially, activities designed to disable or destroy other nations' satellites. This is what we call dual-use technology. SJ-21, the target satellite in this refueling attempt, already raised eyebrows in 2022 when it physically towed a defunct satellite out of geosynchronous orbit. US military officials speculated its potential as a space weapon, and frankly, the line between space tug and space weapon can be uncomfortably thin. Speaking of dual use and strategic capabilities, the Space Force is contracting with SpaceX for something called MILNET, a secretive government-owned, contractor-operated satellite communication network in low Earth orbit. This network will eventually comprise over 480 satellites operated by SpaceX and will be integrated into the Space Force's hybrid mesh network plan. MILNET will use SpaceX's Starshield terminals, which offer enhanced encryption over the commercial offerings. This is part of a larger Golden Dome missile defense system, a $175 billion project that's been compared to the Manhattan Project. However, the Golden Dome faces congressional skepticism, and frankly, for good reason. There's a lack of concrete information about how it's going to work, and there's concerns about triggering a new arms race. The scale of ambition is impressive, but the execution challenges will be enormous. The recognition that space is becoming a contested domain is driving significant investment in space situational awareness. Astroscale just secured a £5.15 million contract from the UK's Defence, Science and Technology Laboratory to lead the Orpheus mission, advancing space situational awareness and weather monitoring capabilities. This investment comes with good reason. Lloyd's of London has warned that severe solar storms could lead to global economic losses of up to $2.4 trillion by disrupting navigation, communications, and defense systems. When you add the threat from hostile activity and orbital congestion, space situational awareness becomes a national security imperative. The European Space Agency is responding with the first phase of its Earth Observation Government Service, or EOGS, a satellite imaging system designed for both civil and military applications. The goal is ambitious: all-weather imaging with 30-minute temporal resolution, a massive improvement over the once-daily European systems. This push for better Earth observation capabilities is creating opportunities for commercial companies that are reshaping intelligence gathering. Planet Labs has recently secured a seven-figure deal with NATO to provide AI-enhanced surveillance capability, leveraging their PlanetScope constellation. But there's tension brewing in the US market. CEOs from Maxar Technologies, Planet, and BlackSky are urging Congress to reject proposed budget cuts to commercial remote sensing programs. The Trump administration's 2026 budget proposal includes a roughly 30% reduction, about $130 million, for the NRO's procurement of electro-optical imagery, and completely eliminates funding for synthetic aperture radar imagery. This is particularly problematic because these commercial companies have invested billions in satellite constellations based on sustained government demand. The cuts contradict Pentagon policy, emphasizing greater commercial integration, and, as the U.S. Chamber of Commerce warned, could jeopardize America's technological leadership in a critical area. While nations compete for strategic advantage, companies like Varda Space Industries are opening entirely new fronts in space-based manufacturing. Varda is preparing to launch their fourth spacecraft, Winnebago 4, on a SpaceX rideshare mission. But this isn't a normal spacecraft. It's a pharmaceutical manufacturing plant that operates in orbit and returns products to Earth. W4 is Varda's first fully in-house built spacecraft, marking their move towards vertical integration to shorten mission timelines and increase flexibility. The mission will test solution-based crystallization in microgravity, and the capsule features Varda's first fully in-house built heat shield, developed from NASA's CPICA technology. What's particularly interesting is that Varda's reentry capsule serves a dual purpose. They're also being used by military customers for testing technologies in hypersonic flight conditions. This dual-use capability is becoming increasingly common and strategically important. And this is likely the first of many more missions for Varda, having secured a 5-year license with the FAA. Speaking of strategic importance, the European Space Agency isn't sitting idle while others reshape the future of low Earth orbit. With the International Space Station scheduled for retirement around 2030, ESA has signed a Memorandum of Understanding with Blue Origin and Thales Alenia Space to study potential European use of Orbital Reef, Blue Origin's planned commercial space station. This isn't just about having a place for European astronauts to work. It's about maintaining European strategic autonomy in space. ESA astronaut Andreas Mogensen emphasized that Europe wants to be a partner, not just a paying customer, in commercial space. They're already testing this approach through private astronaut missions like Axiom 3 and the recently scrubbed Axiom 4, which focus entirely on science and give what Morgensen calls a huge boost to space station utilization. ESA's preference for working with commercial low Earth orbit destinations that have strong European industry presence makes perfect strategic sense. It ensures European companies remain competitive in the space economy while maintaining access to critical space-based research and manufacturing capabilities. Now let's shift our focus from the orbital realm to the skies closer to home, where aviation is experiencing what I'd call a perfect storm of technological innovation, regulatory adaptation, and market transformation. What's particularly fascinating is how these changes are being driven by both civilian needs for more efficient transportation and military requirements for more capable autonomous systems. Over the last few years, advanced air mobility, or AAM, has moved from PowerPoint presentations to actual hardware demonstrations, and the pace of development is accelerating rapidly. Eve Air Mobility, Embraer's spin-off, unveiled their refined four-passenger air taxi design at the Paris Air Show, and the changes they've made tell us a lot about how the industry is maturing. They've moved from two-bladed to four-bladed propellers on their 8 lifting propellers to reduce vibration. A change that sounds minor but reflects real-world operator feedback about passenger comfort. They've also swapped skis for wheeled landing gear, again based on practical considerations. These aren't just engineering tweaks, they're responses to the reality of commercial operations. Eve's market projections are quite ambitious. They forecast that the AAM industry will generate $280 billion in revenue by 2045, with about 30,000 electric air taxis in service carrying 3 billion passengers annually. They've already secured letters of intent for 2,900 aircraft, the industry's largest backlog according to them, which suggests that there's real market demand, not just speculative investment. What's equally, if not more important, is the regulatory framework taking shape. Senior leaders from major eVTOL manufacturers, Archer, Joby, Beta, and Wisk, are applauding a 5-country alliance between the US, UK, Australia, Canada, and New Zealand to streamline certification processes. This alliance could be a game changer because it creates a pathway for global deployment once a company obtains its FAA type certification. Instead of going through separate certification processes in each country, manufacturers could leverage mutual recognition agreements. This reduces barriers to market entry and accelerates timelines for global operations. While much attention focuses on vertical takeoff and landing aircraft, there's another category that might be equally transformative: electric short takeoff and landing, or eSTOL aircraft. Electra Aero is developing their EL9, and the specifications are impressive. Takeoff and landing in just 150 feet from unimproved surfaces like grass, dirt, and beaches, carrying 1,000 pounds over 1,000 nautical miles. What makes this particularly interesting is a Lockheed Martin Skunk Works partnership with Electra to explore the opportunities, including potential Defense Department programs. This dual-use potential, civilian regional transport, and military applications, is becoming a common theme in aviation development. The military aviation sector is experiencing its own transformation, with autonomous systems moving from experimental concepts to operational capabilities. Australia's demonstration of 2 MQ-28 Ghost Bat drones controlled from an E-7A wedge-tail aircraft represent a significant milestone in what's called the loyal wingman concept. During the test, a single operator on the E-7A took control of the uncrewed MQ-28s, demonstrating their role in flying ahead of and protecting crew assets. This isn't just about adding more aircraft to a mission. It's about fundamentally changing how air operations are conducted by reducing risk to the aircraft operators. The MQ-28's modular design and open architecture allow for tailoring sensors and configurations to specific operational requirements. Future tests will pair the MQ-28 with FA-18F Super Hornets and F-35A Joint Strike Fighters, moving towards genuine crewed-uncrewed teaming. Their strategic implications are significant. This technology could allow smaller air forces to multiply their effectiveness while reducing risk to human pilots. European NATO countries are rushing to develop drone-based electronic warfare capabilities, addressing a critical gap in airborne electromagnetic warfare while reducing dependence on the US. This represents a strategic shift in how electronic warfare is conducted. Italy's Leonardo has taken the lead with their Storm Shroud radar jamming drone, built around the company's Bright Storm jammer mounted on a tech-ever unmanned aerial system. The concept is compelling. Drone-based jammers are cheap, more expendable, and potentially more effective because they can operate closer to threats than crewed aircraft. Germany's Hensoldt is developing the Calatron attack radar jammer, while a consortium led by Indra Sistemas is working on React, a multi-jamming capability for unmanned aerial combat vehicles. Thales has unveiled a miniaturized electronic warfare payload for small drones. This distributed approach to electronic warfare reflects lessons learned from Ukraine about fighting in contested electromagnetic environments. France is taking a different approach to military drone development, engaging 5 local companies to develop competing demonstrators for a medium-altitude, long-endurance drone. This comes amid delays and cost overruns for the multinational Eurodrone program. This competitive approach reflects frustration with traditional multinational defense programs that often suffer from complex work-sharing arrangements and competing national requirements. By fostering competition among domestic companies, France hopes to achieve better performance at lower cost while maintaining industrial sovereignty. The innovation in drone applications continues to surprise. General Atomics and Saab announced a partnership to add airborne early warning and control capability to the MQ-9B Reaper drone. This could provide countries that cannot afford dedicated early warning aircraft with more affordable alternatives. The MQ-9B AEW and C could detect tactical aircraft, guided missiles, and drone swarms at a fraction of the cost of crewed platforms. The UK Royal Navy is already considering this capability for their aircraft carriers, facing an emerging AEW and C gap as their Sea King helicopters retire without immediate replacement. Lockheed Martin's Skunk Works has begun flight tests on their common Multi-Mission Truck X (CMMTX) vehicle, a low-cost collaborative combat aircraft that could be a candidate for future increments of U.S. Air Force Collaborative Combat Aircraft program. This attritable approach, designing aircraft to be affordable enough that losing them in combat is acceptable, represents a fundamental shift in military aviation thinking. MBDA has unveiled what they call a low-cost, low-range effector, essentially a kamikaze drone for high-intensity warfare. With plans to produce 1,000 units monthly, integrating a 40-kilogram warhead and jet engine with 500-kilometer range. This represents the industrialization of one-way attack drones. It's a sobering reminder of how modern warfare is evolving. One of the most technically exciting developments is RTX's achievement of positive thrust with a rotating detonation combustor in a jet turbine. This signals the growing maturity of a combustion method that could revolutionize both military and commercial aviation. While still in development, RDC technology promises to be as transformative as the original jet engine. The implications extend beyond aviation to space propulsion, power generation, and any application where combustion matters. As we wrap up this week's deep dive, what strikes me most is how these developments are interconnected in ways that we couldn't have even seen a few years ago. The competition for cislunar space infrastructure directly affects terrestrial geopolitics. Military drone development is accelerating civilian autonomous aviation. Commercial space manufacturing is enabling new defense capabilities. European efforts to reduce dependence on U.S. space assets are driving innovation in both military and civilian sectors. We're witnessing significant shifts in how aerospace and defense capabilities are developed and deployed. The traditional boundaries between military and civilian, national and commercial, terrestrial and space-based systems are blurring. Companies that succeed in this environment will be those that can navigate these intersections most effectively. The strategic implications are profound. Nations and companies that master these emerging technologies, orbital refueling, autonomous systems, advanced propulsion, space-based manufacturing, will have decisive advantages in both economic competition and military conflicts. Those that fall behind risk technological dependence and strategic vulnerability. I'm curious to hear your perspectives on these developments. Which technologies do you think will have the most transformative impact? How do you see the competition between nations and companies playing out? What challenges and opportunities do you see for the industry? And most importantly, did I miss anything? Let me know your thoughts in the comments below. If you found this analysis valuable, please hit that like button, subscribe to the channel so you don't miss our next On the Radar. Thanks for joining me today in this comprehensive look at the aerospace industry. See you next time.